So we continue with our future value for compound interest. In this scenario, we're going to be determining the interest rate. Now keep in mind that as you read any of these problems, you're not going to be told what you have to find. You have to be able to decipher it as you read the problem. So here it says, once she turned 18 years old, Kaki received $45,000 from a trust fund established by her grandfather. She placed the money in an account that was compounded quarterly. She got married on her 25th birthday and withdrew the money to help pay for her wedding. By then, the trust was worth $73,775. What was the annual interest rate that Kaki had for her account? So we know that this is the future value for compound interest. So that's FV times P, that's our principal, 1 plus the rate divided by the pay periods, raised to the n times t power. Now I like to go here, read through it slowly, and determine all the variables that we have. So it says once she turned 18 years old, Kaki received, here's our $45,000. So that's our principal. From a trust fund established by her grandfather. She placed the money in an account that was compounded quarterly. Quarterly, that's 4 times a year. 4 compounds. She got married on her 21st birthday and withdrew the money to help pay for her wedding. If she received the money on her 18th birthday and then withdrew it on her 25th, that means she had it in the bank for 7 years. By then, the trust was worth $73,775. So here's our initial point. Here's our ending point. So her future value, $73,775. And of course, what we need to find is R, the interest rate. We're going to be solving for R. So we have a future value, $73,775. That's equal to our principal, that's $45,000. One plus the rate, which we don't know, that's what we're trying to find. This is the variable that we're solving for. Divided by the number of compounds and number of pay periods, that's 4, it's quarterly. How long does this rate, how many times per year, I should say, does this rate affect this? 4 times. What is the length of the deposit? 7 years. So we'll use some algebra. We will divide both sides by $45,000. Of course, these will cancel. That's the whole idea. So then in our calculators, 73,775, and divide that by the 45,000. There we go. That's 1.63944444. We're still going to go on the rule of thumb as 8 decimals. And that's going to be equal to, that's our 1 plus R over 4. And then 4 times 7, that's the 28th power. Now what we're going to do is we're going to use the power rule of exponents. So I'm going to raise this to the 1/28th power. Because the power rule of exponents then says that these are going to cancel. That's the whole idea. That's why we do it. However, algebra says what I do on one side, got to do it over here. So I'm going to raise this to the 1/28th power. So I already have it in my calculator here. So I'm just going to go to my caret key. And as you can see, the A and S, That's this answer right here. I'm going to raise that to the 1 divided by 28, which is the 1/28th power, and hit enter. So that gives us 1.0178 124. That's going to be equal to 1 plus r over 4. We continue with our algebra. We need to isolate this term here so we can get to the variable. We'll subtract 1, subtract 1, 0.0178, 124. That's equal to r over 4. Continuing with algebra, we'll multiply both sides by 4. These will cancel. So I'll take 4 times 0.0178, 124. Hit enter. So then the rate is approximately equal to 0.071249.6. So the rate that CACI had deposited the $45,000 at, that was an simple annual interest rate of around 7.125%. And there we go.